and welcome to Kaizen Academy's 10th live webinar. Today we are going to discuss the key guidelines for how to design a lean value stream. My name is Ahmed Radwan and I'll be your host for this session. Whether you're joining us from the factory floor or an office or halfway across the world, we're thrilled to have you here today. Before we dive into our topic today, let's get to know each other. So where are you tuning in from today? Drop your location in the chat and let us know where you're based. I'm joining today from Melbourne, Australia. Nice. US, Pakistan, Italy, Turkey. Good. UK, Texas. Nice. Greece, Italy. Nice, nice. Before I forget, I've dropped a link in the chat because you're supposed to get an attendance certificate to this training. So if you didn't, only if you didn't register in today's webinar before joining, you didn't fill out your details before, just fill out this form to make sure that your certificate will be ready. Okay? If you filled out your information before, you don't need to fill this out again. It will be considered waste. Good. South Africa, Peru, Netherlands, USA. Fantastic. So it looks like we have a truly global group today. So now let's get started with the key guidelines of a lean value stream. So here is a quick roadmap of what we will cover during our time together. So we will start with a brief introduction to value stream mapping. We will understand its what and why. Then we will deep dive into the key essential guidelines that make a value stream truly lean. And stick around because at the end we are having an exclusive offer designed to help you take these learnings to the next level and get certified as a lean practitioner. Finally, we'll open the floor for your questions in our Q&A segment. So a value stream encompasses all the actions, both value added and non-value added. So this is what a value stream means. And this value added and non-value added activities are the activities that are required to bring a product through its main flows, including the production flow from raw material into a product that is ready to be delivered to the customer, and the design from, for example, from a concept to launch, so from the beginning to end. And when we adopt a value stream perspective, it means that we are focusing on the bigger picture and we are improving the whole, not only part of the process or a single focus of the process. And a practical starting point for mapping and implementing lean processes is to examine the door-to-door production flow inside a plant, which includes both shipment to customer and also delivery of supplied parts and materials from our suppliers. Within the production flow of a factory, while the movement of material is commonly recognized, so when we talk about the flow, usually what comes to our mind is the flow of material, how the product is moving from being like spare parts or raw material into a final product. This is commonly recognized. But there is also a critical flow, which is the flow of information that directs each process on what to produce next and by which quantity. These two flows together are interconnected and must both be mapped for a complete understanding of the value stream. if we focus solely on point improvement by concentrating our effort in one specific area of interest, we run the risk of missing out on numerous opportunities, or in some cases, even having a negative impact. For example, you may improve the productivity of a production step that's not a bottleneck and it's already faster and has a shorter cycle time than other processes. Um, in this case, you might end up with creating an overproduction or overly produced quantity that you don't need, and your effort might ultimately be in vain. So, Kaizen efforts or any lean manufacturing technique are most effective when applied strategically within the context of building a lean value stream. So the value stream maps permits you to identify every process in the flow and build an entire value stream according to the lean principles. So this is like the value stream. But why? So from this, why value stream mapping is an essential tool? So value stream mapping is a crucial tool for visualizing the entire material and information flow. This is what makes it unique and distinct and essential, and identifying the sources of waste within a production process. Moreover, it establishes a common language for discussing workflows, and it ties together lean principles to prevent isolated improvements and also serve as a blueprint for comprehensive door-to-door lean implementation. So what I was trying to say here is, if you do focused improvement or like point improvement in an area here and there randomly, whenever you find an opportunity for improvement, you just improve. This is good and nice, but you need to also think about using a holistic way to see what what is the impact of your improvement on the whole value stream or the end-to-end process in terms of the process, the material flow, and also on the information flow. The scope of today's session is not necessarily about how to draw a value stream map, but we will only like go through like the basic components of a value stream map in terms of drawing it. But today's scope is more about if you have a current situation or a current map or a current value stream map, how to identify or how to transform it from the current condition to the future state. So when you in the current state map, we capture usually the as is situation, and we use some of these symbols to achieve that. So for example, we use the manufacturing process as in this rectangular shape. Underneath, you will have some key information about the process in terms of, like, for example, cycle time or the changeover time and so on and so forth. You would use this symbol to represent the inventory. You would use this symbol to represent the number of operators, and so on and so forth. Okay. And also you can use these or you usually use these kind of symbols to represent the information flow. Like for example, the manual information flow will be like this. Electronic information flow, automated flow will be like this. And also some other symbols that you can use. And this is the details of these symbols and how to use them and when is beyond the scope of today's session. So for example, like this is a complete as is process map, and as you can see here, in the right hand side up to the in the right hand side in the upper area, you will find here the customer and the key information about customer demand, and also you will see here how the customer interacts with the production control, or how like the sales department or the planning department that is interacting directly with the customer, in terms of, for example, the forecast and also the orders, actual orders. And also you will see in the left-hand side up here the suppliers icon, which represents the key suppliers providing you with the raw material. And down here you will find your production or the material flow, which is the flow of the material from being a raw material supplied by the supplier until it is ready for shipping. So all of this is the material flow, and starting from the supplier, coming here, and then ending to the customer again. And also, as you can see here, all of this is information flow. For example, in this case, the production control department would schedule every session, every process individually. In this case, using like daily shipping schedule or daily priority list and so on and so forth. Down here, you will see the timeline, which is a very unique and very nice tool within the value stream mapping, which would show you the value added versus non-value added time. So for example, here you can contrast the lead time, which is 48 days, to the value added time, which is only a few minutes. And everything between those two values is opportunity for improvement. Okay, so this is a very quick overview on how the value stream map looks like in a current state map. Now we are going to talk about the values, what are the guidelines to make a value stream lean. Fundamentally, making a value stream lean is a journey of continuous improvement. So it's not just a single destination, not one-time effort, but a series of incremental advancements. You will find that you will not need just one future state map, but a succession of future state maps, each one moving you closer to the ideal leaner operation. Okay. So if we talk about a leaner operation, it's fundamental for us to talk about the most significant source of waste, which is overproduction. So overproduction is not just about making too much, but it's about producing more sooner or faster than is required by the next customer process. So as you can see here in the slide, it directly causes excess inventory, hidden defects, long waiting time, and rework. And what does that mean? It means that each process produces and pushes product forward based on its own schedule, not based on like a trigger from the customer process or an actual need from the customer process. And customer process, we always call it the downstream process. And the result of this is pure moda, pure waste. Material is handled, counted, like the overly produced or early produced material is stored, counted, and it's not because it's not yet needed. This also means that we have defects that can remain hidden in the inventory queues until much later, making them extensive and difficult to trace. Ultimately, while the actual value added time of production might be very short. So the total time of a product sitting down, doing nothing within the factory spaces, it makes the eventual lead time journey very long. So how do we achieve this smooth, waste-free flow vision? Fortunately, there are 7 key guidelines that provide a roadmap for a lean value stream, and this is what we will explore together today. So today we will focus on produce to tact, achieve continuous flow, use supermarkets, and schedule only one process. Also, we're going to cover level the production mix, level the production volume, and also every part every. And we're going to pay a special focus to the first four. So our first guideline is to produce to your takt time. And takt time, it's a German word, and it indicates a kind of a rhythm. And takt time is essentially the heartbeat of your production. And it tells you how often should you produce one part or product to meet the customer demand. And it's calculated by dividing your available working time per day or shift by the customer demand per day or shift. And this reference number will help you, which is calculated in usually in seconds or a unit, a time unit. It helps you to synchronize your production pace with sales and clearly see areas for improvement. While it sounds simple, achieving this requires concentrated effort, ensuring faster response to problems, eliminating unplanned downtime, and crucially, eliminating or minimizing the changeover time in the downstream process. And this is where the real challenge and opportunity lies. So basically, the takt time is the balance that helps you know whether you are overproducing or not. So, for example, if your customer requires from you to produce 100 pieces every hour, and you're producing 200, it means that you're overproducing. So to calculate the takt time, there is a simple formula for this, and it is calculated by dividing the available time per shift by the customer demand per shift. So, for example, if the available time per shift is 27,000 seconds and the customer demand per shift is 455 parts, this means that the takt time is 59 seconds. In other words, we should be producing, so our production rhythm or speed should be producing one piece every 59 seconds. Okay? If you produce faster than this, it means that you're overproducing. If you produce slower than this, it means that you will not be able to satisfy the customer demand. Okay, right. So let's test your understanding of takt time, drawing on the principles that we have discussed. So calculate the takt time for this operation. A manufacturing plant operates 8 hours a day. During this time, they have two 15 minutes scheduled break per shift. So 30 minutes breaks of break per shift. The customer demands 2,800 pieces per day. So what is the takt time? Please note that the 15 minutes breaks wouldn't be regarded an available time for during the shift. Yeah, of course, like the shift duration is different from one organization to another according to the policies. I need the answer in seconds. No, not right. Okay, we're getting good answers here. Nice. That's correct. So let's see how it is calculated. So first, we know that the net available working seconds is 450 minutes, which is which is the 8 hours per day multiplied by 60 minutes, which 60 minutes, which will be 480 we will subtract 30 minutes of the breaks from that time. So this will be 450 minutes multiplied by 60 to convert that into seconds. So we have 27,000 seconds per shift. And the takt time will be calculated by dividing the 27,000 seconds over the 2,800 pieces. So the takt time in this case will be 9.64 almost, or 10 seconds. Okay, so this is the correct answer. Thank you all for who tried, and thank you all, and well done for those who answered it right. Okay, so this is the first thing, which is very important. The first principle is very important because, as I said, the takt time, if you're faster than the takt time, means that you are overproducing. If you're slower than the takt time, it means that you are underproducing and therefore causing a shortage to your customer or the customer process, right? And if you don't know the takt time, it means that you don't know what you're doing, basically. So next, let's go to the second guideline, which is strive to develop continuous flow wherever possible. And by continuous flow, we mean that each item flows immediately from one process step to the next without stagnation. And this is the essence of continuous flow. Basically, a step produces one piece and it moves directly to the second process without any kind of stagnation or inventory or stoppage. And it is the most efficient way to produce. And on your future state map, in many cases, this means combining multiple separate processes into a single cell to achieve flow. And while I can hear you saying now, while like this is not possible in every case, and that's correct. So while continuous flow is ideal, we understand it might not always be immediately achievable everywhere. And a pragmatic approach is to start with a combination of continuous flow and also some pull systems, and gradually expand the continuous flow as reliability improves and changeover time is reduced. Like, for example, if your changeover time is 1 hour, you cannot just produce one piece and then and then do another changeover, right? So because it would be meaningless. So but it becomes more realistic when you reduce your changeover time. So if you look at this batch and queue scenario versus the continuous flow processing scenario, what is the advantage of the batch, of the continuous flow processing over this, or what are the disadvantages or the problems with the batch and queue production scenario? What is the problem with it? Yes, we have inventory and waiting. Problems will be hidden, longer lead time, and also space requirements. So what happens when continuous flow simply isn't possible? Perhaps processes are too fast, like they are not compared to each other, too fast or too slow, or even geographically distant, like we have like suppliers in different countries even. So in these instances, we use supermarkets to control production. So our third principle is use supermarkets to control production where continuous flow doesn't extend upstream. So in these cases, you will have to have inventory or a buffer between the different stages, or between you and your supplier. And the case here is that you put a very strict control system on your inventory so that it is replenished based on the actual needs, not just by doing overproduction. So instead of having these uncontrolled inventory spaces, we will link the processes or we link these supermarkets or this inventory to their downstream customers via a pull system. And you can think of a supermarket as a controlled inventory point. The customer process withdraws what is needed, and this withdrawal triggers the upstream supplying process to replenish what was taken, right? So we use production Kanban to trigger the production and trigger production, and we use the withdrawal Kanban as a shopping list for material handlers. So in these cases, we avoid the guesswork and we ensure that production is always aligned with actual demand. So this process wouldn't be able to withdraw anything without Kanban, and this process wouldn't be able to produce anything without a Kanban, and the supermarket arranges all of this. To simplify scheduling and amplify lean benefits, our fourth guideline is to try to send the customer schedule to only one production process. And and it's a process that sets the pace for all the what we call the pacemaker process will be the process that will be scheduled, the only process that's going to be scheduled, and this will control the flow of all the other processes. And the objective of this is to avoid having every process separately scheduled, which would necessarily eventually mean that we are not producing according to the actual demand. So the pacemaker process, for example, in this scenario, the pacemaker process will be scheduled to process number 4, and all the other processes will be producing according to the actual schedule here of the pacemaker process number 4, because process number 3 is connected to process 4 via supermarket, and also the same thing between process 2 and process 3, and process 1 and process 2. And the pacemaker process is always the process that is the last working cell, or the last continuous flow process in your value stream. So these were the first 4 key principles that we went through. So we have 3 remaining guidelines, which we will cover quickly compared to the first 4. So our 5th guideline addresses a common pitfall, which is scheduling long run of one product type to minimize changeover. So in some cases, like in some factories, to avoid the time wasted in changeover time, you would just schedule longer batches of every product, which would result in overproduction and also extra inventory. While this seemingly good or efficient for one process, like that requires a long changeover time, this batching creates severe problems for the entire value stream, leading to excessive finished good inventory and amplifies inventory surges upstream. And the solution is to level the production mix. It means basically distribute the production of different products evenly over time and alternating repeatedly between smaller batches. And by doing so, at the pacemaker process, you drastically improve your ability to respond to the diverse customer requirements. So because you are able to change over or change the products that you produce in a very responsive way to your customer demands. And we usually use this OX icon as a symbol visually representing this leveling in the future state map. And we also have another principle, which is leveling the production volume. So the previous one was leveling the production mix. This is talking about the production volume. And basically it means instead of releasing large batches of work to the shop floor, which would create kind of chaos because there is no takt time is not linked to what you schedule, and the uneven workload and difficulty to monitor and increased lead time. So to counteract this, or instead of this, you establish a consistent level production pace through what's called the paced withdrawal. And this means regularly releasing small, consistent increment of production instructions at the pacemaker process. So you don't schedule the pacemaker process for a week, for a complete week, or even a day, but you try to reduce that scheduling interval so that you are very responsive and you avoid the problem of producing too much more than what your customer would require. Okay? And I understand that like passing through these last two principles was relatively quick, but I will share with you these slides after the meeting to read it carefully, because of the time limitation. And a powerful tool for leveling both mix and volume is what's called the load leveling or Haijunka box, where Kanban are placed in a desired sequence and withdrawn at a small increments, and which will result in synchronizing the production. Finally, our seventh guideline, which is related to the sixth guideline, is called every part every. Basically, how often do you produce all of your most common or runner products? Are you producing all your products within a week, which means like all of your product types within a week? So for example, you dedicate if you have 7 products and you're working 7 days a week, do you produce one product every day? Or you produce 2 of them every day, or 3 of them, or the 7 of them every day, right? If you produce the 7 of them every day, it has great advantage, because this will allow you to be more responsive to your customer demands. But at the same time, it comes with the cost of the requirement to change over very frequently. So in the first scenario, you change over once per day. In the second scenario, you change 7 times per day. And there is a well-established technique to achieve a reduced changeover time to counter the long changeover time, which is called who knows the process to change to reduce the changeover time. What is the tool to reduce the changeover time? Exactly, Chris. It's the single minute exchange of die, which substantially reduces the changeover time. And by shortening this time, upstream processes can respond much faster to downstream needs, requiring even less inventory in their supermarkets. So there are like very known inspiring stories from Toyota where they had like in their chassis they needed to have a changeover time of 3 days, and they managed to reduce it to 11 minutes, which allowed them to be more responsive and more agile. So to recap, our journey to a lean value stream is guided by these 7 powerful principles. Produce to tact, setting the pace with the customer demand. Develop continuous flow wherever possible, which would result in eliminating any stagnation. Use supermarkets where continuous flow cannot extend upstream, controlling production via pull system. Schedule one pacemaker process and simplifying your entire production chain. Level the production mix, ensuring responsiveness to the varied customer needs. Level the production volume, creating predictable, consistent flow with paced withdrawal. And finally, strive for every part, every day, shift, or even hour by reducing changeover times. I can see many questions coming up in the chat. We will dedicate some time to answer all of your questions, so get ready with them. So these guidelines, when applied, create a truly transformative effect on your operations. But here is the crucial point. Merely understanding these concepts or principles is obviously not sufficient, and it is just the beginning. And the real tangible benefits, the cost saving, the quality enhancement, or the reduced lead time comes from hands-on application, from doing the work and embedding these principles into your daily operations. And this is where many organizations or continuous improvement practitioners would face the challenge of bridging the gap between theory and practical sustainable implementation. And this is precisely why we are so proud of our Lean Practitioner certification and coaching program, because it is not just another course, it's a comprehensive program designed to equip you with the practical skills and confidence to implement these guidelines effectively in unity with other Lean concepts and tools. And this program is designed to empower both aspiring and experienced professionals with the skills and strategies needed for operational excellence and continuous improvement. And it provides an immense value for your career advancement, helping you to gain a competitive edge and provide enhanced organizational value. You'll benefit from hands-on learning. We'll talk about that now, and applicable across various industries, all within flexible learning options and a one-to-one support from your coach. So, our Certified Lean Practitioner program follows a structured yet flexible certification process. You will progress through the self-paced learning modules. So we have Lean and TPS fundamentals module, and we have a separate module about value stream mapping. And we also have the scientific problem solving learning module, in which you will learn the 7 quality tools and A3 methodology. And then you will go to the second milestone, which is the certification project coaching. And in the certification project, you will apply value stream mapping and lean principles to a real world scenario within your own organization. And this project includes the invaluable one-to-one coaching and utilizes the powerful A3 methodologies. And the journey completes with a comprehensive exam, finally, to confirm your mastery of lean principles. And this holistic hands-on approach ensures that you just don't learn about lean, but you become a lean practitioner. And here are some details about each module. These are the learning modules, and this is the certification project module, and finally the final module, which is the exam.